Welcome everyone. Today's topic is understanding the abstract transaction program, which is a detailed overview. So I welcome everybody, and I thank my tutor, Mr. Ashish Manjandana, for giving me this opportunity to present on this topic, and my mentor, Mr. Sun Tran. So we will be exploring the key object-oriented programming concept using a practical example of a transaction program. We'll cover inheritance, polymorphism, abstraction, and encapsulation, showing how they are applied in our code. So here you can see that the as the program runs, it shows a menu with opening an account, withdrawing amount, deposit amount, transfer amount to someone, print your balance, print your transaction history. So here how the program overall looks. As you can see, there are four concepts inside uh, object-oriented programming. First is inheritance, then comes abstraction, then comes encapsulation, and at the last we have polymorphism. So object-oriented programming is a programming paradigm based on the concept of object. These objects can contain data in form of fields and codes in form of procedures or methods. So first of all, we will be discussing about the inheritance within the within our code. So the deposit and the withdrawal classes inherit from the transaction class, and reuse of common method properties are there. And as you can see in the transaction class, there are three classes that are being uh, inheriting the functions uh, f- from transaction class, which is the deposit transaction class, transfer transaction class, and the withdrawal transaction task. So inheritance, first of all, is the mechanism by which one class can inherit attributes and methods from another class. So deposit and withdrawal are classes of transaction. They inherit common properties and methods from transactions such as the initialization method, get amount method, while providing their own implementation to the process method to handle specific transaction types. Moving on to another topic, we have the polymorphism. So polymorphism actually allows object of different class to be treated as an object of a common superclass. The function process transaction demonstrates polymorphism by accepting any object that is an instance of transaction or its subclass. It calls the process method on transaction object which behave differently depending on whether the object is a deposit or a withdrawal. So as you can see, the uh, class transaction class is actually having two methods, rollback and execute, and they are all showing polymorphism. Next, we can move on. As you can see, these three classes of withdrawing transaction, transfer transaction uh, are all rolling back and executing the same time. Then comes the abstraction part that we are having. So the abstraction allows us to define the structure of an object without detailing its implementation in our program. The transaction class is an abstract-based class. It contains the abstract method process, which defines the general interface for processing transactions. This method must be implemented by any subclass, ensuring a common structure while allowing different implementations. As you can see, there are some of the abstract method, like the abstract class transaction, so that it is the complexities must be hidden. Similarly, there are many methods like public class, public abstract bool success, which hides the successful transaction of the thread, and at last we have the public abstract void print, which actually hides the overall printing of the actual message at the last. So moving on, we have another concept called as encapsulation. So encapsulation is basically the bundling of data and method that operates on that data within a single unit or class and restricting access to some of the object components. In our transaction class, the amount attribute is protected and not directly accessible from outside the class. Instead, we use the get amount method to provide control access. This helps protect the integrity of the data and prevent unintended interference. So as you can see that private protected, the amount is privately, and it's not globally, so nobody can access it from outside the program. As you can see, there are classes that are read only because they are having a public allowance. So what will happen in here is that the data time and the execution will all be uh, accessed from outside the program. So there is a high vulnerability to the program. And the oops, we have the paradigm overall that is inside there. So as you can see, the first when a customer initiates the transfer, it goes to bank, and when it goes to bank, it goes for find from account, and it goes to account class. The after verifying the from account, it goes back to the bank, and from the bank, it goes. If in case the account is not found, then it will return not found. So, and in that case it is found, then it is uh, go sent back to the bank to verify the account. And if the in that case also, if the account is not found, then it is returned. And if the account is found, the check is withdrawn from the account, and again this verification of the amount is going on. For at the last, the overall transaction details has been printed at last. After that, the withdrawal amount is then the things come in the three classes of withdraw, deposit, and transfer. If anybody wants to withdraw amount, then it goes to the withdraw transaction amount, and then the amount withdrawn can be sent back to the account in similarly. And in case if somebody want to deposit, then it goes to the deposit amount transaction class, and then it returns back when the message of deposit successfully. And in another case, if the somebody wants to has transferred some money from the account, then the transfer is shown directly to the account with a transfer successful message, and all of the messages that whether it's withdrawn, deposit, or transfer, all of them are shown at the last. So moving on towards the conclusion of the VPT, we have seen our inheritance, polymorphism, abstraction, and encapsulation are applied in our transaction program. These concepts work together to create a flexible, maintainable, and scalable code base. Using O principle allows us to design programs that are easier to understand, extend, and debug. So thank you for your attention. I hope your this presentation has been informative, and I open the case for any question and answers. Thank you.